Uh, this was the last topic which I have done. Now I'm continuing with bound charge. Crossing a given surface. See, I am strictly speaking here about a non-polar dielectric. Here I am speaking strictly about a non-polar dielectric material. Suppose there is no electric field, you already know there is no charge. There is no polarization. There is no, what do you call, separation of positive charge density from the point of negative charge density. No stretching of molecule and all that. Now you imagine a space. Now imagine some material in the form of just showing an arrangement. You are seeing a portion of a small dielectric like this. Is that you are seeing a dielectric slab. Again, in this when very small elementally. What is that you are seeing is a dielectric material, and this is an elemental. For this elemental area, normal is in this direction. You know already normal is always perpendicular to the surface. And in this region, you have electric field E bar making an angle theta with this norm. What will happen? You already know there is some polarization. In the process of polarization, positive charge is will move in the direction of electric field, negative charge opposite to that. So basically, the polarization or dipole moment is aligned along the direction of the field. Now we consider Q is charge, T is distance between positive charge and negative charge of a dipole. I think till here there is no doubt. If someone asks me what is the dipole moment of a molecule, you will simply say QD. Till this point, any doubt? Right. I am assuming N is number of. See, be sensitive about this. N refers to number of charges per unit volume. Number of charges per unit volume. Right. Okay. N refers to number of charges per unit volume. I have started just now. Please follow. Bound charge considering a surface is the concept. Where I am speaking about the basic construction of a non-polar dielectric material. I am speaking about one dipole, one molecular dipole, basically. Means like this. Something like this. So the charge is Q. T refers to the distance between the positive and negative charge of a dipole. And dipole moment is Q into T. N stands for number of charges per unit volume. Any doubt till this point? Right. See, because that you have delivered electric field, Remember, this is the surface level. Hello. Whatever the surface I am representing here, that I am representing here now. Now the issue with me is, in this is the normal direction, ds. And this is the direction of the electric field. Now I imagine, one such dipole you take you assume minus plus. That is how it is oriented. I am giving a microscopic picture of one dipole in an area selected. Now try to please understand this further be divided into two surfaces. Above the other. By the way, this is totally D. So therefore, the component in this direction is d cos theta. Which means now I would like to give you a clarity. This distance is d by 2 cos theta and this distance is d by 2 cos theta. Suppose if there is no electric field, nothing is crossing that surface. Because there is electric field, a positive charge crossed above that reference level, a negative charge crossed below that reference level. Now I'm stopping over here. You have any doubt? Ask me right now. Blindly don't stuff content into your brain. I'm asking you again, are we clear? If there is no electric field, nothing to discuss. Because that there is an electric field, this reference surface, positive charge crossed upwards, negative charge crossed downwards. Okay, fine. Now what do you want? What my point is, positive charge crossing, okay, upwards. I'll represent that as some delta Q, and remember this is a bound charge and this is a plus. Can you please help me in writing this? Anyone in the class? How much charge? Upwards. Very simple. This is some volume again. Whatever the charge right now in this volume is earlier nothing. Hello? When there is no electric field, nothing is there here. Now because you have applied electric field, some positive charge have crossed this surface, settled in this volume. Now you already given n is the number of charges per unit volume, n into, right? Volume, n into A into, A is a small area, delta S into d by 2 cos theta into Q. Agreed? Boys and girls, agreed. The first part represents total charge because N represents charge per unit volume. This is the volume term. Into N gives charge into Q. I challenge, this theory is not at all available even in HC1, even in NCERT. So I am giving this from different book collections for another book collection, right? You refer even in internet also for 11th, 12th class level, no teacher will give this information, right? Now, positive charge crossing upwards is this. Similarly, negative charge crossing upwards, delta QB minus is almost the same. d by 2 cos theta into q. Now remember, net charge crossing the given surface is this plus this. Are positive charge crosses up, negative charge crossing down. So net is sum, not zero. Suppose if the amount of positive charge cross on upwards is same as the amount of negative charge cross upward, net charge is zero. Here, different thing is happening. Positive charge is going up, negative charge is going down. So net you should add. Current and ante kada. You took the same way. Suppose positive charge is moving from left to right, negative charge is moving from right to left. Negative charge moving from right to left is equivalent to a positive charge moving from left to right. Same here also. So therefore, it is nothing but n delta s d cos theta q. Let that be delta q bound charge. And I will rewrite this properly. N q d d n q d delta s cos theta. Have you ever identified what is NQD? NQD is the total dipole moment or your polarization vector dot delta S bar. So if you ask me bound charge cross a given surface because of applying electric field, I'll simply do hereafter P bar dot ds bar. Remember, when I am writing this, dipole moment per unit volume. That is the reason why I have written polarization vector. Now, please try to understand this equation, this particular equation which I have applied, delta QB, which I have applied. This one, particularly which I have applied, equation holds good for a very small elemental area. Elemental area. Remember, I have selected one elemental area and I have drawn all the observation at one elemental area. Delta is area. Right. Equation holds good for every small elemental area inside dielectric. Don't forget, we are still taking homogeneous isotropic dielectric. So it holds good inside dielectric. Okay. To find net charge flown out of a closed surface. Okay. So simply, we will equation 1, you will integrate it like this. dqb is p bar dot ds bar. Are duplicate form of Gaussian actually. I am still finding it in some form of Gaussian only, actually. Finally. Right. Now, we need to identify one point here. Overall, is the dielectric neutral or charged? Any in the class? Because of the fact that I have applied electric field, is the dielectric neutral or charged? Hmm? which means you see some net charge. Wrong. Where do you get charge from? Tell me. Because of polarization. Polarization involves dipole. For every negative charge, there is an equivalent positive charge. Now tell me again. I'm asking you the question. In this state, is there any net charge for the dielectric? Do you find any net charge for the dielectric? Sure. Sure? No, there won't be any net charge. So overall, dielectric was a neutral. So I should comment one point here. Suppose a positive charge is coming up, an equivalent negative charge goes inside. So therefore, charge flown out of closed surface must be, this is a very important point, focus on this, must be a negative of charge enclosed inside the surface, which means this is some dial of random shape. This is the space that I'm enclosing. Because some charge is going out due to polarization, I will say that net charge enclosed inside. So therefore, this can be written as P bar dot ds bar is QB out, which is the same as minus QB. This is a wonderful relation which we will use later on. So therefore, if you want a very precise form, that's it. I want that relation now. I'm asking you, you have any objection in any form of these steps which I have written here? Please ask me comfortable. Boys and girls. Any doubt? Clear? Right. Now you are applying electric field. Because you have applied electric field, polarization took place. Already in my previous class, I have said polarization depends on the extent of the electric field. Are cause and effect. And the proportionality constant is there. That I have represented as susceptibility. Do you remember? Last class I have uttered this. So now I just give some focus on it. Even in H.C. Verma also, you don't find all this theory. Whenever there is a net electric field, when there is a net electric field, E bar inside a dielectric material, you see that it is in the state of polarization. Polarization is directly proportional to electric field. So P is proportional to E. And vectorially, you will write this as E bar. And this term is what we called as susceptibility. Remember, this is purely property of the material. And out of non-polar and polar, two I have introduced. Polar dielectric, you can use this for both polar as well as non-polar. But polar dielectric will have higher susceptibility. Of course, it, it will decrease with increase of temperature. Can you explain why? Why susceptibility decreases with the increase of temperature? Susceptibility tells me about the number of dipoles oriented in the direction of the field. Indirectly. Right. Now, what happens when temperature increases? What happens to the dipoles when temperature is increased? Thermal agitation will disturb the orientation. Oh, good section, good teacher. Students will be organized in their sitting pattern. They won't get disturbed. But suddenly there is some noise outside. Even though they are good students, they are a good teacher, some disturbance is noticed. Now, last section, good teacher, outside noise. Tell me, what happens? What happens? The class will be completely disturbed. Same thing is noticed here. Temperature will disorient the dipole's orientation with electric field. Next, it will mean susceptibility will decrease with the increase of temperature. And I use different words, dielectric constant, or you can call this as relative permittivity. You know, this is related to RK. You use whatever the no issues. This is equal to 1 plus susceptibility. Same relation we will study in magnetics also. Magnetism also, you will get such relation. Right. Okay. Next. That's all. The basic theory is done from my side. Now we will again do one question. A very good question from Irido. Good. 1 minute. Try this question. Permittivities E1 and E2 means you can convert that to dielectric constants in our language. No issues. What is the capacitance of the capacitor? First question you already know. This is what you have. K2, you can see that. Right. Here it is D1, here it is D2. Remember, if you study this circuit in this way, till you require certain maturity, it is very difficult to operate for you. I told you a technique for this. So how you will write this? You will write this as an arrangement like that. This is capacity C1 and this is capacity C2. Right. And I have given dielectric constant K1, K2. In the place of permittivities, area, don't get confused. Your epsilon 1 is K epsilon naught K1 and your epsilon 2 is K2 epsilon naught. Last I will convert. What is the capacitance of this arrangement? C1 is nothing but K1 epsilon naught A by D1 plus K2, here, 1 minute. That is the C1. C2 is K2 epsilon naught A by D2. Till here, there is no doubt. So they are in series. So yes, effective capacitance is C1, C2 by C1 plus C2. So here epsilon naught A will become common and that will become K1 by D1, K2 by D2 divided by K1 by D1 plus K2 by D2, right? And this further can be written as epsilon naught A, okay, K1, K2 by K1 D2 plus K2 D1. That is the C. That's it. Epsilon naught A, K1, K2 by K1 D2 plus K2 D1. Any doubt till this point? Right. Now let us study the second part. The surface charge density of the bound charges on the boundary plane. If the voltage across the capacitors is equal to V and electric field is directed from layer 1 to layer 2. Right. Which means now I will write a spacious diagram. To avoid confusion, I will write a spacious diagram. And don't say that there is some air between the plates. Mana. For our understanding, I am writing an elaborated diagram. Right? Assumed to be here the charge is plus Q, here the charge is minus Q. Okay, no issues. Here the charge is minus Q1. Yeah, of course. Here the charge is plus Q1. Here the charge is minus Q1. Here the charge is plus Q2. Any confusion till this point? మీరు మరీ అసలు మాటలు రాని వాళ్ళు పాట ఉంటున్నట్టు వింటున్నారు రా. నీ చెప్తోని ఎక్కుతుందో లేదా నాకు డౌట్ వస్తుంది. Are we clear? Good. I have given one formula. Do you remember? Small q, capital Q terminology. I have given you one formula. Can you please help me in writing that Q1 is Q times 1 minus 1 by K1. What about Q2? Q2 is nothing but Q times 1 minus 1 by K2. He is not asking that. I think he is asking here, by the way, Q is, okay, if you convert this into sigmas, sigma 1 is sigma times 1 minus 1 by K1. Sigma 2 is, these are all bound charges, 1 by K2. Now the only issue is, what's happening over here? This I want. At the green zone. What's happening at the green zone? Can you please help me in writing what is happening at the green zone? There is sigma 1 minus sigma 2. Read out, boys and girls. Remember, this is all positive charge. And this is all negative charge. I need to take it in that fashion only. So finally, what is this going to be? Can you please help me? Sigma 1 minus sigma 2. Minus sigma by K1 plus sigma by K2. So sigma times 1 by K2 minus 1 by K1. You said the density is sigma dash, but sigma was not at all given. So whatever that they are asking, sigma dash is a sigma times 1 by K2 minus 1 by K1 is not your answer. What is sigma? Q. Clearly, Q is equal to CB. C means effective capacity. So clearly, Q is equal to epsilon naught A K1 K2 by K1 D2 plus K2 D1 times V. By the way, sigma is nothing but Q by A, which is nothing but epsilon naught V times K1 K2 by K1 D2 plus K2 D1. Any doubts till this point? I have done the question then, which means this is nothing but sigma V by K1 D2 plus K2 D1 times K1 minus K2. Boys and girls, any doubt in the process that I have done this particular question here? Boys and girls, very particular about this. Any doubts? You're not saying anything. Yes or no? Clear? Paka? Right? Next. Sure? Right. Very good question, actually. So next question, I think we will try to do these questions in order actually. 103, 103. Right. Next, we require to do one more problem, almost the same lines. 10, the question which I have done is 103. Previously, the question which I have done is 101. I require to do one more question in this. Easy question only. I require 102. Yes. Try this, everyone. They're all very good questions, actually. మీరు ఎలక్ట్రోస్టాటిక్స్ కంప్లీట్ ఇరుడో చేస్తారా చేయలేదా? ఎలక్ట్రోస్టాటిక్స్ కంప్లీట్ ఇరుడో చేయలేదా? Make it fast. So, what to deal with this particular question? Two parallel plate air capacitors, each of capacitance C, were connected in series to a battery of the EMF E. Then one of the capacitors are filled up with the uniform dielectric with permittivity K. No issues. How many times did the dielectric strength in that capacitor decrease? What amount of charge flows through the capacitor? Simple. Now try to please understand what is happening over here. You have two capacitor plates like this. Two capacitor plates. C2. And this is earlier with almost C1 is equal to C2 is equal to C. So therefore, initially, what is the picture here? Can you please help me? What is the equivalent capacity now? C by 2, because they are in series. Plus CV by 2 minus CV by 2 plus CV by 2 minus CV by 2. Initially. Finally, what is the picture? Finally, again, you have the same plates. Now, this will become Kc and this is C. What is the meaning of epsilon? Epsilon is nothing but K times epsilon. Now tell me, what is the C equivalent now? What is the C equivalent now? K into C by Kc plus C. This is nothing but K by K plus 1 times. Now, what is the first charge drawn by the battery? Q is C equivalent into V. K into C by K plus 1. Please tell me, what is the final charge right now? K by K plus 1 CV, which is more than 0.5. Are K by K plus 1 obviously will be more than 0.5. It is because if it is K by 2K, 0.5. K by K plus K, 0.5. You are using something lesser than that. So therefore, fraction is more than 0.5. Further charging takes place. Now here it is Q dash. Previously Q is CV by 2. Now it is Q dash minus Q dash plus Q dash minus Q dash. Now what is happening? Delta Q is Q dash minus Q. K by K plus 1 CV minus CV. This is 2K minus K minus 1 by K plus 1 CV by 2. K minus 1 by K plus 1 times CV by 2. More positive. So therefore, extra delta Q charge is transferred by the battery. Now, what are the questions that you posed me here? How many times that the electric field strength in the capacitor decrease? What amount of charge flows through the battery? Right. Already second part I have answered. Right. Initially, E initially is simply V by 2D, because that is potential difference by distance. Potential drop is V by 2 initially, and the distance between the plates is D. You did not agree. No issues. Another way I can answer. I want electric field. Electric field is potential difference across the first plate by distance between the plates. Potential difference across the first plates initially is V by 2D. I'm assuming distance between the plates are identical, dt, because you said capacitance are identical. Can you please help me? What is the final potential difference? V1 is to V2 is in series. The capacitors are in series. V1 is to V2 is related to 1 by C1 is to 1 by C2, which means 1 by K is to 1, which means 1 is to K. Now tell me what is V1. V1 is V by, అరే 1:k ని V1 కి ఎలా వేస్తారు చెప్పండి? Anyone in the class? V1 is to V2 is 1:k. What is V1 term? V1 by V2 is 1 by k. V1 by V1 plus V2 is 1. మన కర్మ ఏంటంటే ఇవి కూడా చేయాల్సి వస్తుంది. అది ఇంత స్టాండర్డ్ తక్కువ ఉంటున్నారు. V1 is V by k plus 1. Now, E final ఏమవుతుంది? E final is potential drop now V by k plus 1 times D. Now you will say U initial minus E final V by 2D minus V by k plus 1D. So V by D common you take k plus 1 minus 2 by k plus 1. It is nothing but k minus 1 by k plus 1 times V by D. What is this, by the way? This is how many times did the electric field strength in that capacitor decrease? Decreases by this much times. K minus 1 by k plus 1 times V plus D. Decrease in electric field in first capacitor. Or the capacitor where dielectric is inserted. Now, please tell me, do you have any doubt in anywhere, any step related to this question? Anywhere, any step. Q I have given already. CV by 2 times K minus 1 by K plus 1. In the plate where dielectric is introduced, the decrease in field is K minus 1 V by K plus 1 V by T. That's the deal. Please refer the question. Two parallel plate air capacitors, each of capacitance C are connected in. Then one of the capacitor is filled with the uniform dielectric with permittivity E. How many times the electric field strength in that capacitor decrease? This is the relation. K minus 1 by K plus 1 times V by T. But sometimes what will happen is they don't accept this answer. Why? Because they did not given anything about D. So then what people will do is E initial minus E final by E initial. This gives fraction. So this becomes K minus 1 by K plus 1 times V by D by V by 2D. V by D, V by D will cancel. 2 times K minus 1 by K plus 1. So decreases by 2 times K minus 1 by K plus 1. Any doubt? You feel free to ask me on this. What I have done, the total potential difference divided by distance between the plates is the electric field inside the plate. సరే నువ్వు నిద్రపోతున్నారా? వింటల్లా ఏం వస్తా బుక్లో చూస్తే వస్తుందా? 10 మార్కులు 5 మార్కులు రావటల్లా ఎందుకు రావడం లేదని మీరేం ఆలోచించట్లా. లాస్ట్ వీక్ ఈ మోడల్స్ మీరు చేశారా కెపాసిటర్స్లో? చేయలే. ఏం వస్తాయి? రైట్, క్లియర్? సో విల్ ప్రొసీడ్ ఫర్ ద నెక్స్ట్ థియరీ, నెక్స్ట్ మోడల్. రైట్, నేను ఎప్పటికీ నోట్స్ నేనే పోస్ట్ చేస్తున్నా మీకు. ఎస్, This is also a very famous model. $3.104. That is the first part of the question. You still have another part. Very good question. If they ask the same question or if they ask a similar pattern in IIT, they'll ask almost in the same way. Read a book is so good for that. Now you try. Next step of the problem is now you have the capacitor plate like this. At a particular portion, let this be dx. What is this elemental capacitor? K at that position, because this is at a distance x. K at that position, epsilon naught A by dx, which means epsilon naught A K1 plus K2 minus K1 by d times x by dx. Can you please help me how those elements are from x is equal to 0 to x is equal to d? Yes, exactly. They are in series. అప్పుడు ఏం రాస్తారు 1/dCAగా మీరు చేయాల్సిందే 1/C effective is 1/dC, which means 1/epsilon naught A times dx by K1 plus K2 minus K1 by d times x. This you can write it as 1 by, again, I'm repeating, is in the form of 1 by A plus bx dx. This can be written as 1 by b log e A plus bx2 by A plus b x1. Do you know this integration? If not, I mentioned it right now. This integration step. Now, by applying which, you'll get d by k2 minus k1 log e k1 plus k2 minus k1 by d times t, because you're integrating it from x is equal to 0 to t by k1 plus 0. So you will get 1 by epsilon naught a d by k2 minus k1 times log e. Arey bhaiya, ye d cancel. You will finally get k2 by k1. So therefore, effective capacitance of the system is epsilon naught A by d times K2 minus K1 by log E K2 by K1. This is the first part of the question. Any student having doubt on this part, Please ask me. Srinidhi followed. Any doubt? Noora. Clear? Martin Akada. Martin. Have you followed? Clear? Any doubt till this point? One by okay, right. What is a series effect? 1 by C is 1 by C1 plus 1 by C2 plus 1 by C3 plus so on. 1 by DC, 1 by C effective వస్తుంది. 1 by DC, 1 by C effective వస్తుంది. That's what I'm telling. 1 by C effective, how you write? 1 by C1 plus 1 by C2 plus 1 by C3 plus so on 1 by Cn. అదే ఇన్ఫైనైట్ స్మాల్ సమ్మేషన్ అయితే ఇంటిగ్రల్ 1 by DC. Right. That is the first part of the question, which is very easy. Not at all to touch that one. Second part is important. What is the second part? The space density bound charge. The space density of the bound charges is a function of dielectric constant. If the charge of the capacitor is Q and the dielectric and the field E in it is directed towards the growing value of E, which means that is the meaning of the statement. Remember, the first part of the question is absolutely correct. Never wrong in that. Second part is important. Already we have done that question, but still. One thing that they have helped us this term. In the absence of any dielectric, the electric field would have been E. What is going to be the electric field at this point? E naught is simply Q by epsilon naught A. Clear? E naught is clearly Q by epsilon naught A. So what is going to be the electric field at this point? Yesterday also I asked this. Electric field at that point is E naught by K. Dielectric constant at that point. So therefore, E is nothing but Q by K epsilon naught A. That is not the question. What is your question? I can answer this question in two ways. Two ways I can answer. See, try to please understand at this point, electric field is E. At this point, electric field is E plus D. In that way also I can answer. Or else, we have another alternative. We have derived some expressions. Don't forget that. You use those expressions. What are those expressions? Q bound charge is P bar dot ds bar. Have you understood this properly? This in a further language can be written as rho bound is equal to del is a gradient operator. Del bar is nothing but something like dou by dou r cap. dou by dou x I cap, dou by dou y j cap, dou by dou z k cap. Likewise. You can write it like this. Sir, I don't know what is P bar. Just now I have given the expression. What is P bar expression? Susceptibility, epsilon naught, P bar. Why I have derived all those expressions, tell me. Just to keep safe in my notes. Next. Now, rho B is del bar dot susceptibility epsilon naught E bar. Till this point, any doubt? Please ask. Don't hesitate. Boys and girls, you have any doubt? Ask me at this point itself. Now, finally, what is this term going to be? In this case, there is no doubt with the susceptibility term. There is no doubt with K naught term. I have the problem with, in other words, I will write this as minus. That's it. Don't cheat. I am not cheating you because you said the variation is only in the x, whereas y and z, no such variations. By the way, everything is fine. But how to do this? Now, pardon the differentiation part of this is very important actually. Why? I have given you relation for susceptibility also. 1 minute. I have done one mistake. I can allow this when susceptibility is, the material is uniform K. This material is not uniform K. And one more important point, susceptibility also I have given one relation. Can you please tell me that? Dielectric constant at a given point is susceptibility plus 1. Re-enter, you are looking seriously at me as if that I am never taught you this. Today only I have given this information. So therefore, finally, minus del bar dot susceptibility K minus 1 epsilon naught E. What is E? Q by, just now I have given, no? E somewhere I have written. Q by K epsilon naught A. By the way, a epsilon gets cancelled. And finally, what you will have is simply Q is also a constant. So minus Q by A times dou by dou x of K minus 1 by K. This is what you need to do. Remember, K is not a constant here. Or otherwise, rho bound charges minus Q by A times dou by dou x of 1 minus 1 by K. K is a function of x. You know that already. So what is this value? If something is a function of K, what is that? You will suppose I can write K as some A plus Bx. I'm not cheating you, by the way, again. Hello. Hello. You can write this as K1 plus K2 minus K1 by dx can be written as A plus Bx. That is your K. So therefore, d 1 by K, differentiation of 1 by K gives, what is dk? Dk is 0 plus B dx. So what is 1 by K differentiation? It is nothing but 1 by K square dk by dx. Now I am going to use that relation here. Minus Q by A 1 by K square B refers to what? Entama? B. Just please try to K2 minus K1 by D. Okay? Till here, any doubt? Boys and girls? In fact, that is your answer. That is your answer. But suppose if I don't teach this, tell me how you will follow this. How you will follow this? It's very difficult for you. With one single formula, you have solved the entire trick. Otherwise, I taught this question long time back, but it's a lengthy method. Last year, when I taught, it's a lengthy method. Then I felt this theory, if provided earlier, students might do comfortably. That's what in my mind. Now, any doubt, please don't hesitate. Comfortably ask me. That's your answer. That's your answer. Okay. What is this question, by the way? Question number 104. Right. Question number 104. The answer what they have given is the same. K you convert this into another terminology, epsilon 2 minus epsilon 1 by epsilon square. Any doubts? Pakka? Now again, I am going to teach concept. I have done 3-4 problems. Now, have you understood what is the major tool for solving these questions? Concepts taught by you. Just with single formula, can you manage these questions? You know some formula. Can you manage these questions? No, not possible. Next, force on a dielectric slab. Remember, when I said a dielectric, or when I said a parallel plate capacitor, we have compromised certain areas in that. I said a dielectric basically means so and so, likewise. But actually, the dielectric will experience a force if it is a partially inserted. Why? Because there is a concept called fringed electric field. I will explain that very clearly right now. Practically speaking, at the edges of a capacitor plate, the electric field lines are like this. Such field lines are called fringed field lines. I am repeating again. Actually, till now, ideal condition is that you felt uniform. Yes, it is uniform undoubtedly when you are going deep into the capacitor, almost somewhere over here at this point. But as it is outside, as you go away from the center, in this direction or in this direction, in this region, fields are not uniform. They are curved. You can see such a fields are called fringed fields. Okay. Now, therefore, what is happening at this point when a dielectric is introduced? Now I am introducing a dielectric here. In this case, dielectric is introduced between plates of a capacitor. Between the plates of a charged capacitor. There is no battery here, notice. So this comes under constant charge case. Now, because of this fringed fields, the dielectric slab gets polarized and this will experience an inward force also. So how to calculate that inward force? How to calculate that inward force? Now at this instant, what is the total energy stored? U is half, what do you call, the potential difference between the plates. I'll take it as V. Now, for example, unless or until you write, you generally you'll write it as a Q square by 2C. So if I write what is du by dx, see here Q is a constant quantity, right? Q is a constant quantity, right? Q is a constant quantity. You can write this as a Q square by 2C times 2C. C is value. C is a function of X. Yes or no, yeah? At every instant, as you change X, the capacitance of the capacitor changes. So therefore, this is dC by dx. Please answer my question carefully. Have you understood this clearly or not? I did not touch the charge at all. Why? Obviously, it is constant. Now, what is going to happen? Now, a conservative force can be represented like this, which can be written as dC by dx. So this is the inward force experienced by the dielectric. Can you please help me in writing what is the C in this? C is nothing but C1 plus C2. Of course, parallel. Oh, by the way, this part, they are between the two parallel plates. So therefore, what is C1? Can you please help me? C1. Epsilon naught area. If I am taking the total length as L, for example, length into width is area. So therefore, in the place of width, I can write A by L. So this can be written as X A by L divided by distance between the plates D, and of course, dielectric constant is K. Now, please answer my question. Have you followed this stuff? Open to every student here. Have you followed? Arey, have you followed? Second student. Noora. Pakka. Right. Can you help me in writing the remaining part? Epsilon naught. Yes. L minus X. A by L divided by T. So therefore, finally C is epsilon naught A by LT common Kx plus Kx plus L minus X. So C is epsilon naught A by LD times K minus 1x plus N. Now, what is dC by dx? Simply epsilon naught A by L into D times K minus 1. Okay. Therefore, finally, what you will write is F is minus Q square by 2 square. dC by dx is epsilon naught A by LD K minus 1. Remember, this is the conservative force. Minus sign indicates attract. Always into that. So this minus sign, negative sign indicates that attractive always inwards. Always inwards. Can I ask you a question? Yeah. ఎందుకు ప్లస్ వస్తుంది? డిఫరెన్షియేషన్ లో మైనస్ ఎక్కడ వచ్చింది? రైట్ మైనస్ వచ్చింది. ఓకే, ప్లస్ ప్లస్. బట్ స్టిల్ నువ్వు నోటీస్ చేసినట్లయితే డినామినేటర్ చూడు, ఎప్పుడు కూడా it is a decreasing term. It is a change as x increases. And one more important point, F is not constant. F is not constant. Always it will experience inward force. That is the reason why even you just leave into the groove, the dielectric moves with an acceleration into the capacitor. That is the reason why we will always hold the dielectric outside so that it goes slowly into the capacitor. Otherwise, it will trigger currents and heat loss is noticed. Any doubt on this, please ask me right now at this point of time. Students, this comes under what category? Constant charge case. This comes under constant charge case. Any doubt? Now we will move on to constant voltage case. When I say constant voltage case, what is to be observed? Basically, it should be connected with some battery. So this is also called a suction force. You call whatever it may be, force on dielectric or suction force. This is coming under the suction force on dielectric slab with battery connection on. Battery connected. This comes under constant voltage. Potential difference is constant. You speak of anything here, what is the energy at any instant? Now I will change my version. Previously, I have done q square by 2c. Now I will change my version of cv square. But still, it is the same c. Remember, it is the same c. It is the same c. Now, what is the dc by dx here? What is f, which is nothing but minus half v square dc by dx, which is nothing but v square by 2 times v square by 2 times epsilon naught a by ld times k minus 1. Are here? Entire right hand side, everything is constant. Do you see any variable term in this? V constant, A constant, L constant, D constant, K constant. So this is constant. So what I have understood is with battery connection on, attractive force is always a constant. It's a constant force. Previously, a variable force. But most of the cases, we will get questions like this only. I'll give you one HC Verma question on this. But meanwhile, if you still have any doubt on this, please ask me very clearly. If you have any doubt on this, please ask me. Don't hesitate. There is a famous HC Verma question on this, actually. I'll discuss that question right now. Very famous question. This is question number. Please, can you try this? In this question, it shows a two parallel plate capacitor. And don't forget, I want formula. And this is the formula here, which I need to remember. Remember, this is a constant. Formula required. Now, on K1, this will experience F1 force. On K2, it will experience F2 force. Can you please help me in writing F1? F1 is nothing but V square by 2, magnitude only, epsilon naught A by L1D K1 minus 1. What about F2? F2 is V square by 2 epsilon naught A by L2D into K2 minus 1. Honestly, say yes or no for this. Neglecting. Find the ratio of EMF of the left battery to that of the right battery, or left battery to that of the right battery. Right. So that it remains in equilibrium. What is required is the condition for equilibrium. For equilibrium, the condition is F1 must be same as F2. V1 square by 2 epsilon naught A by L1D K1 minus 1 is V2 square by 2 epsilon naught A by L2D K2 minus 1. Epsilon naught A, D cancel, 2 cancel. By the way, V1 by V2 whole square is K2 minus 1 time L1 by K1 minus 1 time L. That's the condition. And just identify if anything else I missed in that. Yes. Who said the area is not the same? Width B. Oh God. Then I should write A1, A2. Hold on. Thank you. So in that case, A1 by L1 becomes width B. A2 by L2 becomes width B. Then what will happen now? D is the distance between the plates. At least that is right. Width B. Distance between the plates not required. They will get cancelled now. When I make F1 is equal to F2, what is going to happen? Tell me. Simply now, V1 square times K1 minus 1 is equal to V2 square times K2 minus 1. So V1 by V2 is under root K2 minus 1 by K1 minus 1. We will call this as V1, this as V2. Any doubts? Thank you. Eliminated. Areas are not same undoubtedly. Any doubts? So force depends only on width, not on A by L fact actually. Any doubts? Pakka? Sure? HC Verma model. Now, if you know this formula, almost you are done. May I proceed for the next question? Sure? The next question is also from HC Verma. Very simple. You still again require the same question. F is equal to V square by 2 epsilon naught width times K minus 1. And D is all epsilon naught width by D. Right. Consider the situation shown in the figure. The plates of the capacitor have plate area A and are clamped in the observatory. So you cannot write in terms of width, no, you can write this in K minus 1. Remember, it is a constant force. So that the slab will execute periodic motion and find its time period. Remember, it's already inserted by A and relieved. So it L minus A distance is left. This L minus A distance, it will travel with a constant acceleration. Half into A into T square. L minus A is half. Acceleration is force by mass. V square epsilon naught A by 2 L D M K minus 1 T square. So finally T is, no, that is not your answer. Don't forget. 4 M D L times L minus A by epsilon naught A K minus 1 times V square. Okay, then what happens? Now you need to see this is the stage 1. Thereafter, what happens is, say the slab will completely occupy the space and it will have maximum velocity at this stage. Next, what happens? Same force earlier which was accelerating this now will decelerate this. And hence, what happens? This interval is t is equal to 0 to t is equal to t1. And now what will happen is at this stage, again, the slab will come to rest. This is a rest. It will come to rest with a space only occupied inside. You know, here to here, acceleration. Here to here, deceleration. Starting from rest to maximum velocity. Maximum velocity to rest, which means the same time. So which means, now again, this stage is like t is equal to t1 to t is equal to 2t1. And this process keeps repeating. So now tell me, is this not a periodic motion? Yes, it is a periodic motion. Is it SHM? No, because force is constant here. For SHM, force must be proportional to displacement. Here, force is constant. So it is oscillatory, but not SHM. And the total time period is 4t1. So therefore, the total time period is, I think they are asking total time period only. 4 into under root 4 m d L minus A by epsilon naught A K minus 1 V square. So this will become 8 times L minus A times L m d by V square epsilon naught A K minus 1. Same thing. That's all. So that is all for today.